Cyclohexane is a cycloalkane with the molecular formula 6. Cyclohexane is mainly used for the industrial production of adipic acid and caprolactam, which are precursors to nylon. Cyclohexane is a colourless, flammable liquid with a distinctive detergent-like odor, reminiscent of cleaning products. Production and reactions. On an industrial scale, cyclohexane is produced by hydrogenation of benzene. Producers of cyclohexane accounts for approximately 11.4% of global demand for benzene. The reaction is highly exothermic, with IH 500 K, I 1/2 equals 216.37 kJ per mole. Dehydrogenation commenced noticeably above 300 degrees Celsius, reflecting the favorable entropy for dehydrogenation. Historical methods. Unlike benzene, cyclohexane is not easily obtained from natural resources such as coal. For this reason, early investigators synthesized their cyclohexane samples. In 1867, Marcellin Berthelot reduced benzene with hydrochloric acid at elevated temperatures. He incorrectly identified the reaction product as N-hexane not only because of the convenient match in boiling point, but also because he did not believe benzene was a cyclic molecule but rather some sort of association of acetylene. In 1870, one of his skeptics, Adolphe von Baeyer, repeated the reaction and pronounced the same reaction product hexahydrobenzene, and in 1890 Vladimir Markovnikov believed he was able to distill the same compound from Caucasus petroleum, calling his concoction hexanafton. In 1894 Baeyer synthesized cyclohexane starting with a Dieckmann condensation of pimelic acid followed by multiple reductions. In the same year E. Haworth and W. H. Perkin-Jr. prepared it via a Wurtz reaction of 1,6-dibromohexane. Surprisingly, their cyclohexanes boiled higher by 10 degrees Celsius than either hexahydrobenzene or hexanafton, but this riddle was solved in 1895 by Markovnikov, N. M. Kishner, and Nikolai Zielinski when they reassigned hexahydrobenzene and hexanafton as methylcyclopentane, the result of an unexpected rearrangement reaction. Reactions. Cyclohexane is rather unreactive, being a nonpolar, hydrophobic hydrocarbon. It reacts with superacids, such as HF plus SBF5, which will lead to cracking. Substituted cyclohexanes, however, may be reactive under a variety of conditions, many of which are important in organic chemistry. Uses. Commercially, most of cyclohexane produced is converted into cyclohexane-cyclohexanol mixture by catalytic oxidation. Ka oil is then used as a raw material for adipic acid and caprolactam. Laboratory uses. Cyclohexane is sometimes used as a repellent organic solvent. Cyclohexane is also used for calibration of differential scanning colorimetry instruments, because of a convenient crystal-crystal transition at 87.1 degrees Celsius. Heat treating equipment manufacturer Surface Combustion uses cyclohexane as a gas in their high-purity vacuum carburizing furnaces. Conformation. The 6-vertex ring does not conform to the shape of a perfect hexagon. The conformation of a flat 2D planar hexagon has considerable angle strain because its bonds are not 109.5 degrees. The torsional strain would also be considerable because all of the bonds would be eclipsed bonds. Therefore, to reduce torsional strain, cyclohexane adopts a three-dimensional structure known as the chair conformation. There are also two other intermediate conformers: half chair, which is the most unstable conformer, and twist boat, which is more stable than the boat conformer. This was first proposed as early as 1890 by Hermann Sachs, but only gained widespread acceptance much later. The new conformation puts the carbons at an angle of 109.5 degree. Half of the hydrogens are in the plane of the ring while the other half are perpendicular to the plane. This conformation allows for the most stable structure of cyclohexane. Another conformation of cyclohexane exists, known as boat conformation, but it interconverts to the slightly more stable chair formation. If cyclohexane is mono-substituted with a large substituent, then the substituent will most likely be found attached in an equatorial position, as this is the slightly more stable conformation. Cyclohexane has the lowest angle and torsional strain of all the cycloalkanes, As a result, cyclohexane has been deemed a zero in total ring strain, a combination of angle and torsional strain. This also makes cyclohexane the most stable of the cycloalkanes and therefore will produce the least amount of heat when burned compared to the other cycloalkanes. Solid phases: cyclohexane has two crystalline phases. The high-temperature phase I, stable between 186 K and the melting point 280 K, is a plastic crystal, which means the molecules retain some rotational degree of freedom. The low-temperature phase II is ordered. Two other low-temperature phases 3 and 4 have been obtained by application of moderate pressures above 13 Pa, where phase 4 appears exclusively in deuterated cyclohexane. Here Z is the number structure units per unit cell. The unit cell constants A, B and C were measured at the given temperature T and pressure P. See also, the Flixborough disaster, a major industrial accident caused by an explosion of cyclohexane. Hexane, cyclohexane, references, ABCM Larry Campbell. Cyclohexane in Ullmann's Encyclopedia of Industrial Chemistry, Wiley VCH, Weinheim, 2012. doi, 10.1002/14356708 Pub 2, Frederick Fan Zhang, Thomas Van Rijman, Ji-Soo Kim, Alan Cheng on present methods of hydrogenation of aromatic compounds, 1945 to present day Lungs-Chiniskaha paragraph GSKOL8 2008, Market Study Benzene, Sarasana, July 2011, 1, Warnhoff, E.W. The Curiously Intertwined Histories of Benzene and Cyclohexane. J. Chem. ed. 73, 494 doi, 10.1021/Edo 73 p. 494 c. Berthollet Nouvelles Applications des Marques Copyright Thodes de la Copyright d'Action en Chimie Organique, Bulletin de la Société Copyright Tar Copyright Chimique de Paris, Series 2, 7 of 53-65. Berthollet Marque Copyright Thode universel pour la Copyright de l'Aérosatradiodragon les Composer Copyright S Organiques, Bulletin de la Société Copyright Tar Copyright Chimique de Paris, Series 2, 98-31. From page 17, en effet, la benzine, chauffe copyright EA 280 a degree pendant 24 heures avec 80 fois 100 poids dans solution aqueous satura copyright EA Freudtzide iodhydrique, say change a pu promise enchérament en hydrodixylane, C12H14, en fixant 4 fois 100 volume d'hydrogène, C12H6 plus 4 hours do equals C12H14 a euro le nouveau carbe former copyright par la benzine est encore unique et dar copyright fni, il but a 69 a degree, a oft outslay. Propria copyright tar copyright essay la composition de l'hydrodixylane extrait des par copyright trolls. Is wrong because chemists at that time used the incorrect atomic mass for carbon. By fixing, that is, combining with 4 times its volume of hydrogen, C12H6 plus 4 hours do equals C12H14 a euro. The new carbon compound formed by benzene is a unique and well-defined substance. It boils at 69 a degree and presents all the properties and the composition of hydride of hexylene extracted from oil. Adolf Bayer Weber die Reduction aromatische Kohlenwasserstoff durch Jodphosphonium, Annalen der Chemie und Pharmacie, 155 a 266-281. From page 279, bei der Reduktion mit natem Amalgam oder Jodphosphonium adheren Psychem H paragraph CHSTEN Fall 6 Atom Wasserstoff, und is Instenapke paragraph Mling, die Psych von einem Kohlenwasserstoff C6H12a Billiton. Dieser Kohlenwasserstoff ist alle Wahrscheinlichkeit NaChe in geschlossener Ring, das ein Derivat, das Hexahydromesethyl und Hexahydromelitse Currency mit Leichtigkeit wieder in Benzolabke paragraph Mlinger 1/4 Bergu 1/4 HRT Werden Car paragraph NNEN. Price, DM Temperature Calibration of Differential Scanning Colorimeters. Journal of Thermal Analysis 45, 1285 a euro 1296. doi, 10.1007/BFO2547423A, A.B. Mayer, J. Urban, S. Haubrilo, S. Holdener, K. Natkanik, I. Wangen-Kortereflinger, A. Zajac, W. Neutron scattering studies of C6H12 and C6D12 cyclohexane under high pressure. Physica status cell ID 166, 381 doi, 10.1002/PSSB 2,221,660,207 External links, International Chemical Safety Card 0242, National Pollutant Inventory Cyclohexane Fact Sheet, NIOSH Pocket Guide to Chemical Hazards, cyclohexane at 3DCHEM, Hermann Sachs and the First Suggestion of a Chair Conformation. NLM Hazardous Substances Data Bank cyclohexane, methanol discovered in space, calculation of vapor pressure, liquid density, dynamic liquid viscosity, surface tension of cyclohexane, cyclohexane production process flowsheet, benzene hydrogenation technique.